Now we're going to take the same transportation problem that we discussed previously, but we're going to set it up in a slightly different way. Now, when this particular way may seem to be more complicated than the previous one, and of course it is, but only slightly. But the advantage is that when you model it in this fashion, lot more variations of the basic problem can be easily incorporated, as we will see. So there are a lot of different things we can do if we set the model up in this fashion. So here, let's first look at in what way the numbers are set up here. So we have one column for origin node and one column for destination node, and we have the unit cost is given here. So instead of having 3 plants and 4 destinations and having the shipping cost in a table like this, we have it as one column, origin to destination. So origin 1 to 4 destinations, origin 2 to 4 destinations, origin 3 to the 4 destinations. And we have 2 sets of constraints here, capacity constraint and demand constraint. So these are the 3 plants with capacities given. So let's color code them. And then we have the destinations or regions, the 4 regions, and these are the demands for those. Okay. Now let's go ahead and name these. Okay, so these are the 3 columns. Let's name the 3 columns. Okay. Now let's name capacity and demand. Then we're going to have a column called flow. Flow is the quantity that flows in these arrows. So each row here is an arrow going from one origin to one destination, and that's what we have to determine. So that's our changing cells. Okay, and let's name the changing cells. Okay. Now we have to calculate how much outflow there is going out of each of these origins, and we have to calculate how much inflow there is coming into each of the regions, and we're going to use a function called SUMIF. So SUMIF, you provide the conditions for which flow should be added up. So here we want the flow to be added up to be only the origins 1 in the first case. So if origin is 1, we want to sum those flows. In the second case, we want to sum the flow only when origin is 2. Okay, and the third case, we want to sum the flows only when the origin is 3. So the SUMIF function functions in this way. It'll sum only if the condition is true. So what is the condition? So SUMIF the origin, okay, that's your range, is equal to the criterion. Okay, if the origin is equal to 1, then you sum this column. So this will sum the quantities flowing out of plant 1, and that should be less than or equal to the capacity. So let's align that. So now you copy that. Okay. Now inflow also works the same way. So now flows are coming in, so you need to look at the destination. If destination is equal to the region number, then you sum the flow. So this will sum the flows coming into a given region, region 1 in the first case, and we want that to be equal to the demand. Okay, so let's name these 2 ranges. Okay, And then we have the total cost. Total cost now is the sum product of flow with the unit cost. So we have sum product of flow comma unit cost. So that will give us the total cost. Let's name total cost. Now that's our objective function. So let's color code that. That's it. Now we can run solver. So we want that to be minimum. Now by changing cells is our flow. Okay. And the constraints are outflow less than or equal to capacity. Add that. Inflow is equal to demand. Okay, that. Make non-negative. Simplex LP. You solve and you get the answer. So this is the same problem like we did before, and you will see that the answer is same as before. Okay, we are just modeling it in a different way. We're using the sum if function. That's the key. By using sum if function here, we have modeled it in a way that we can change this model to accommodate various new additions, and bells and whistles can be incorporated quite easily.